All right, so here we're going to have a look at question 13. Now this is question 13 from the Advanced Maths HSC paper from 2020. This is an integration question. It's one of the first integration questions in the paper. This one is not too bad if you know how to use the formula sheet. So we have the integral from 0 to pi on 4 of secant squared of x dx. Now this is immediately slightly unsettling for some students because they're only used to doing integrals of x or x squared or sine or cosine or e to the x or stuff like that. When they see secant or cosecant or cotangent or sine times cosine squared, these slightly more complicated ones, they get a little bit scared and they don't really know what to do. In this case, secant squared is actually listed on the formula sheet in the integral calculus formulas. So we're told on the formula sheet, it's listed in a more general functional form, but we're going to be using it here. The integral of f prime of x times secant squared of f of x dx is equal to tan f of x, I should say, plus a constant. Now, because the formula here is presented as an indefinite integral that has the constant of integration, our question is actually a definite integral though, and the integral we're finding is this indefinite integral where f of x is equal to x. So if f of x equals x, this implies that f prime of x is equal to 1. So we get the integral of 1 times secant squared of x dx is equal to tan of x plus a constant. So we're getting this directly from the HSC formula sheet. The formula sheet formula looks a little bit different, but really this is just the same thing where f of x is equal to x. This is the most simple way this general one could be evaluated. So given that we now know this, we can use this to evaluate this integral. So integral 0 to pi on 4 of secant squared of x dx ends up becoming equal to tan of x evaluated from 0 to pi on 4. So now we need to do our process of calculating the integral. So we'll have tan of pi on 4 minus tan of 0, tan of the upper bound, which is pi on 4, minus tan of the lower bound, which is 0. Now this is a type of answer. It's not a simplified answer. We now need to simplify it. Some students will really mess up the evaluations here. They won't quite know how to work out tan of pi on 3 or tan of 0 or sine of pi or whatever. These ones are pretty simple if you know what the functions look like and if you remember your special triangles. So one of our special triangles is the 1, 1, root 2 triangle. Looks like this. It's a right angle triangle. The base and the height are both 1. The hypotenuse is root 2. Both of the side angles are 45 degrees, which is pi on 4. And so this means tan of pi on 4 is opposite over adjacent. Opposite is 1, adjacent is 1. So this means tan of pi on 4 is 1 on 1, which is 1. So the exact evaluation of tan of pi on 4 is 1. Now tan of 0 we can't necessarily get from this diagram, but if you think about what the tan function looks like, sort of around the origin, goes up this way, goes down over here. This is the y-axis, this is the x-axis, has an asymptote here, and then sort of repeats itself continually over this way, and then continues having asymptotes. It passes through the origin. Because it passes through the origin, this means tan of x, where x is 0, is 0, because it passes through the point 0, 0. So tan of 0 actually is just equal to 0. So 1 minus 0, it's 1. And 1 is the exact evaluation of this integral. In terms of marking, the marking guidelines are a little bit strict on this question. The exact wording that the marking guidelines use is, for 1 mark, find the antiderivative of secant squared x or equivalent merit. Pretty much they want you to find the fact that the integral is tan of x. Right? They don't necessarily need you to do the evaluation correctly in order to get that mark, but they really want you to have tan of x somewhere here. So sort of up to roughly this point will be something like the first mark, and then the second mark will be for correctly evaluating this expression. This one really simplifies quite nicely. It doesn't have, 11 pi on 6 or 9 pi on 4 or these weird sort of angles that might give you, surds or may have to be left in terms of pi or stuff like that. There's none of that going on. You're just getting a 1 and a 0. So to get the second mark, you need the correct solution, which in this case is equals 1. You need to have that value.